that you should have done last year. So hopefully you remember x to the a power times x to the b power is equal to x to the a plus b power, right? You add the exponents when you're multiplying. X to the a divided by x to the b is x to the a minus b. Oops. So when you're dividing, you subtract the exponents. And then lastly, x to the a raised to the b power. This is when you multiply your exponents together. So remember, when we're talking about logarithms, we're talking only about the exponents. So we're going to look at the laws of logarithms. This is section 4.4, and these rules come from the exponent rules. So log base b of r times s, okay, perhaps I should have put parentheses around this, is equal to the log base b of r plus the log base b of s. Okay, so let me show you an example. So log base 2 of 4 times h. So if I write this in expanded form, it means it's log base 2 of 4 plus the log base 2 of 8. Okay, so 4 times 8 is 32. Okay, so the log base 2 of 32 is 5, because 2 to the 5th power is 5. Okay, and then if I look on this side, log base 2 of 4 is 2, and log base 2 of 8 is 3. Right, so you can see that 5 is equal to the sum of 2 plus 3. So this is kind of an example to show you why it works. Okay, this side is written as one log. Okay, and this side is the expanded form. Okay, now we have a similar law for division. So the log base b of r divided by s is equal to the log base b of r minus log base b of s. Okay, so if we use similar example, log base 2 of 8 divided by 4, is that equal to the log base 2 of 8 minus the log base 2 of 4? So 8 divided by 4 is 2, and the log base 2, of 2 is 1. Let's look over here. Okay, so log base 2 of 8 is 3, minus log base 2 of 4 is 2. So you can see that those are equal. Okay, and then the last is the power rule. So log base b of r to the c is the same as c times the log base b of r. So for example, log base 2 of 2 to the 4th power is equal to 4 times, log base 2 of 2. Okay, 2 to the 4th power is 16, which is 4. And over on this side, log base 2 of 2 is 1, so we get 4 on both sides. Alright, let's start by erasing this. Okay, so we're going to write this in expanded form. Okay, so the log of 8x y to the 4th, we want to write as a sum, difference, or product of logs. So the first thing I do is I look for multiplication. So it's 8 times x times y to the 4th. So I would break this down as log, common log, right, log base 10 of 8 plus log of x plus log of y to the 4th. Okay, and then I think about my product rule. So this 4 can come to the front, so I end up with log 8 plus log x plus 4 log y. Okay, and then down here, this asks us to write as a single log. Okay, so the first thing I would do is worry about my product rule. So I guess I would go in the reverse order that I did the last one. So I would move the 2 to make it an exponent. Oops. And remember that it is the exponent for both x and y. Okay, and then if it's subtraction, that means I can write under a single log the quotient. And then I can simplify this part. So I have x to the 5th, I have x squared and y squared on the bottom. So natural log of x to the 3rd over y squared. Okay, and oops. Alright, so true or false on these. So natural log of x of 2 plus x is equal to the sum. This one is false, right? The sum of 2 logs is equal to the product of what you're taking the log of. So this one is false. Okay, let's look over here. Log base 2 of 5x equals log base 2 of 5 plus log base 2 of x. Perfect. Alright, let's look at this one. The log of x over 4 equals the log of x over the log of 4. Okay, this one is false. The log of a quotient is equal to the difference of the logs. Let's look at this one. Log base 2 of x squared is equal to log base 2 of x times log base 2 of x. This is also false, right? We know that this squared can come to the front. It's actually equal to 2 times log base 2 of x. Okay, what about log base 3 of 7x equals 7 times log base 3 of x? Also false. Right, the log of a product is equal to the sum of the logs. Alright, let's look at the natural log of x divided by 5. That is equal to the difference of the 2 individual logs. That one is true. Okay, and then lastly, log base 4 of x to the 3rd equals 3 times log base 4 of x. Perfect. That one is true. Alright. And what else do we have? Anything? Alright, let's look at just a couple more. So we want to expand log base 2 of the quantity ab squared. We want to expand. So first I look for multiplication, log base 2 of a plus log base 2 of b squared. And then this one I can simplify further. Oops. Okay, and there is the expanded form. Okay, now whenever I see a square root, like on the next one, log base 3 of x times square root of y, I always remember that I change it first to the 1/2 exponent, right? Square root is the same as the 1/2 exponent, so I like to change those right away. So the log of x times y to the 1/2 power is equal to the sum of the logs. The base always stays the same. Right. And then this 1/2 comes to the front. Okay, and then lastly, we have the log of x to the third, y to the fourth, divided by z to the sixth. So, oops, that looks ugly. So, basically anything in the numerator is going to have a positive sign. Anything in the denominator will have a minus in front of it. Okay, so that would be the first step. Break it down into the sum and difference, and then I would bring my exponents to the front. So 3 log x plus 4, oh dear, 4 log of y minus 6 log of z. Alright, and then that's good enough for today.